Hello everybody, and welcome back, after way too long, to Flamethrower's Arduino tutorial series. I stopped making these videos because every time I uploaded them, YouTube destroyed my whole channel's views. But I said, what the heck, ain't no mega corporation gonna stop me from teaching people cool stuff. So we're finally back with the first sensor in this series, and one of my personal favorites, the DHT11. So, the DHT11 is the most common temperature and humidity sensor in the Arduino ecosystem. Yes, it's two sensors packed into one, that's a good deal for you. Specifically, it includes a thermistor, which you'll never guess is the thermometer part, and a capacitive humidity sensor, which, yeah, you get it. A thermistor is just a resistor whose resistance varies with temperature. So in this case, the higher the temperature, the more current will go through it, which allows us to determine exactly how hot the environment is. We'll go into more detail in the next episode about variable resistors. As for the capacitive humidity sensor, it works in a really smart way, by measuring how the dielectric constant of a hygroscopic material in a capacitor setup changes as it gets moist. You got that? Just kidding, I'll explain. The humidity sensor is actually a special kind of capacitor, which is an electrical component that stores charge. It does this by sandwiching what we call a dielectric material between two conductive materials. What the dielectric does is prevent electricity from going from one conductor to the other, and instead gets stored as electric charge in the first one, and its dielectric constant is a number that defines the extent to which this happens. The higher the constant, the more electric charge gets stored at a given voltage. But of course, the DHT11 isn't exactly a normal capacitor. What's special about it is that its dielectric material has a very low dielectric constant, maybe around 5, although it's not known what exactly it's made of, and it's hygroscopic, meaning it can absorb water from the air. And water has a dielectric constant of around 80, so as humidity rises, so does the overall dielectric constant. But how do we actually measure this? Well, the higher the capacitance of a capacitor, so the higher the dielectric constant, the longer it takes to charge it. So, by periodically charging and discharging it and measuring how long it takes, we can tell exactly how much water is in it, and therefore how much humidity there is in the air. Okay, so that's cool, but how do we use it? Well, let's begin with the wiring. It's really simple. You usually get the breakout board module, and in fact it's usually labeled. In this case, you connect your data pin to this pin, VCC to this one, and GND to this one. In case you got the bare sensor, it's basically the same thing, only that there's an unused pin because reasons, I guess, and you also have to connect a resistor like this. But that's it. Now let's get coding. Using this sensor is actually really easy, and this is largely thanks to a library that handles all the low-level timings and stuff for us and exposes a few simple commands we can use. It's the DHT library by Adafruit, and you can get it by looking up DHT in the library manager. Alright, so the first thing we'll do is include the library we just downloaded. So we go to Sketch, Include Library, and then we look for, here, DHT Sensor Library. We don't really need this, I don't know what it does, but yeah. Here we include dht.h, which is the file for the DHT Sensor Library. And the next thing we need to do is initialize our DHT object. And we'll do that by writing DHT, and then we give it a name, let's say unpaid worker, why not? And then we need to state the pin we've connected it to, in my case I chose pin 4, it doesn't need to be a PWM pin, and the type of DHT we're going to be using, in my case the DHT11. If you have a DHT22, well, you write it here, and yeah, with any version of DHT. And the next thing we'll do is introduce the variables where we will store the temperature and humidity readings. Now we could use integers, but that wouldn't really be very precise, so instead we'll use floats, which if you remember are numbers with decimal places. So we'll do float temp and float hum. So this will be our variables. Now, in the setup, as we're going to be reading the data from our serial monitor, we need to call serial.begin, and we'll do 9600 baud rate. And we also need to start our DHT object. So we'll do unpaid, oh my god, that begin, and we don't need to write anything there, so that's it. We can now start taking some measurements. And to do that, we will assign our readings to our variables. So we'll do temp equals, and here we use one of these functions which I said this library exposes for us. And the one for temperature is, well, our object dot read temperature. Oh, there we go. And the same thing for humidity. We'll do hum equals our object dot read humidity this time. There we go. And now we want to print them in the serial monitor. So we'll do serial dot print, because we're going to add later a symbol. We'll do our temp variable, and then just so we know, serial dot print, and we'll add degrees Celsius, because this is, we'll read it in degrees Celsius. If you prefer Fahrenheit, you're weird. Anyway, we do print on, so it prints the next line, because in the next line we're going to be printing the humidity. So we'll do serial print, this time hum for humidity, and then the unit for this will be a percentage simply. There we go. And just so it looks neat, let's just add a line break. There we go. And let's also add a delay so it doesn't like overload the real thing. I'll read every second, for example. So we should now be able to upload this and see our temperature and humidity data in the serial monitor. And there we go. As you can see, I'm getting some readings. Apparently I'm in a very hot and very dry place. But yeah, here you can get your current air temperature and humidity. Okay, pretty easy, right? Well, now let's give it some use, because as my little sensor here can corroborate, we've got that global warm summer weather going on here. So what we'll do is turn on a small fan if the sensor detects it's too hot. But here's the cool thing, because your perception of heat is influenced not only by temperature, but also by humidity. And because we can measure both of those, we can use the much more representative heat index instead. So, first of all, let's wire up our motor. We'll learn how to control them fully in a future video, but for now, all you need is a ground and some pin. Don't worry about switching them around, as this will only make it spin in the opposite direction. Well, you should probably try and get the direction that makes your fan push air instead of pull it, actually. But with that, we can now code it. Alright, so, to begin, same deal as before, we'll do include our DHT library, and then we'll initialize our object, so DHT, this time I'm gonna call it sensor, my pin is 4, and my type is DHT11. And now the variables, float, I'm going to do T for temperature, H for humidity, and HI for the heat index. Alright, now, here in the void setup, we won't really need the serial monitor this time, so we can just set our motor's pin to be output. So remember, pin mode, I chose pin 5, output, there we go, and then sensor.begin. So that's our setup. Now, in the void loop, we're going to call, just like before, T equals sensor.read temperature. Alright, and the same with humidity, sensor.read humidity. And now what we're going to do is calculate the heat index. And well, this has a specific formula with, you know, really fine-tuned constants and stuff. Don't worry, it won't be on the exam. I'll leave it in the description so you can just copy and paste it to get the heat index. Oh, actually, something I forgot first. We would first need to convert temperature to Fahrenheit, because this is from the US National Weather Service. So we'll actually do T equals T times 9 divided by 5 plus 32. This is the conversion from Celsius to Fahrenheit. Okay, so now we have a proper heat index. And what we're going to do with this heat index is, if the heat index is greater than or equal to 80, which is where the National Weather Service advises caution, we're going to digital write our motor pin high. Alright, and then if it's not higher than 80, we'll turn off our motor with digital write 5 low. There we go. Let's add a little delay of 1 second to not overload the thing. Why not? And we should be able to upload this now. Much better. Well, maybe not much. But the cool thing about this is that now that we know how to code a sensor which can take measurements of physical reality, we can use it as a nice source of actual data, which we'll later be able to use to, for example, test different types of displays. And you know what we could also test out? My brand new heat gun from Medusae, of course. Although not face on, as the DHT's limit is 50 Celsius, well, this can reach a whopping 450, which is enough to allow you to solder using air, which is very useful for soldering SMDs. I personally haven't gone into SMDs yet, but it'll prove quite handy when I want to fuse 3D printed parts together. Or for example, remember when I had to use my mom's hairdryer to soften the debond cables when making my steering wheel? Well, now I have a proper temperature adjustable tool. And to top it off, it's extremely cheap, boasting a price typical of the lowest end of heat guns while being extremely high quality and digital. And if you use the link in the description and enter the code Flamethrower at checkout, you'll get it for even cheaper and will be financially supporting my projects while you're at it. Anyway, with that said, please remember to like, subscribe and maybe leave a comment, because not many of my subscribers watch these tutorials, so YouTube thinks they've all lost interest in my channel in general and stops recommending my videos at all, which is why I had stopped making these videos before. But I'm sure together we can beat the algorithm so I can keep this coming. As always, thanks for watching and I'll see you in the next one.